All right, so here we go. We are now going to do the problem that talks about skateboard, pro boards, and specialty boards. All right, so you read the problem and start filling in the chart while I get things set up here on the board. Okay? All right, so here we go. Got anything filled in? Remember, every number in the problem has to go into the chart somewhere. So we've got rows and columns, just like in a matrix. So we got a pro column, and a specialty column, and a finishing row, and a production row. We got to fill stuff in. So, is there a number that goes here? 2? 2.5? Okay, we got to decide what it is.
2. I got 2.
Pro boards require 1.5 production and 2 hours of deck finishing. I'm with you guys that said 2. I'm just reading the problem. Pro boards, 2 finishing, 1.5 production. Good. Now what about specialty boards? 1 hour of production and 0.5 of finishing. How about this $50 and $65? Where does that go? That's profit. So the pro profit is 50 and this is 60? 65, thank you. Okay, now wait, what about this 85? That's the total hours per day available for production. So that would be right here. And what about the 40? That's finishing, that's right here. Is that every number now? Okay. Now, what am I trying to maximize?
Profit.
The profit. And how do I calculate the profit? It's 50x and 65y. We kind of have just gotten in the habit of letting these be x and this be y. It just seems kind of obvious. Does that make sense to everybody? So 50 x's and 65 y's. This one goes down here. It does not get graphed. You remember what we do with this? This is the very last thing we do. What do we do with this guy right here?
We find our answer.
When we find all the points, remember the points on the corners? They get plugged in here. So this is going to wait now. We're not going to do anything with it for a while. Now, what are we going to be graphing? Because that's our next step. We want to graph. This should be an equation right here. This is an equation. 2x plus 0.5y is less than or equal to 40. Kervin, you're kind of staring at me there. Do you get that? Does that make sense to you? That's why I have you put all this stuff in the chart, because this is going to give you an equation, and this is going to give you another equation. So what's the second equation?
1.5 x plus 4y equals 85.
Oh, plus 1y.
Less than.
And then how about those two random blanks that are always left over there? What did we say about that? X is greater than or equal to 0, and y is greater than or equal to 0. Those you don't even really care about because I took care of it with the grid. But man, it's easy points for you. Because you get points for putting the numbers in the chart. You get points for writing the equation, points for writing this, points for drawing the picture. There's tons of points here. So now we're going to draw the picture. Okay? Now, this one, I want you to think about this for a minute. If I cover up the 0.5, y, x is going to have to be 20, right? Right, that's manageable, but look, if I cover up the x, y is going to have to be 80. That's a big number. So I'm going to change the scale on my grid. Instead of letting each block be 1, I'm going to let it be 10. You've done that before, right? Changed your scale? Because otherwise you're going to be counting out 80 spaces and your paper's not big enough. So I'm going to change the scale, and each of these is going to be worth a 10. All right? So here we go. Every block is going to be worth a 10. So I do this equation in purple. So we said if we covered up y, x would be 20. Well, that's right here. So when I label it, I'm labeling it with a 20. And if I cover up this, y was going to be 80. So that first line is right there. Now you need to stop me if you have a question about that. Now shade it. It's less than, so we're going to be shading right in here. Skinny little triangle. Now I'll do this one in red. So now, if I cover up my x, y has to be 85, which is going to be a little bit above that one, right? I need help.
56.7.
What is it?
56.7.
56.7, 20, 30, 40, 50, right there. Oh, this is a weird problem. I think Mrs. Ford may have made a mistake when she wrote this problem. But oh well, this is what we have. And it's shaded below. You see why this is weird? The whole purple is inside the red, isn't it? It's not like they're cutting each other off like they did in our other examples. So where do I look for my answers now? Whatever I have that's purple and red both. So do I have anything that's purple and red both? The whole purple triangle, right. So this corner, and this corner. So now I'll write down my points. One of them is 0, 0, absolutely. One of them is 0, 80. And one of them is 20, 0. So actually, it made it a little easier this time, because remember the other times we had to do some, substitution and elimination? All right, so those are the corners of what we call the feasible region. Now what do I do?
Plug them in.
Take those 3 points and plug them in right here. Obviously, if I put in 0 and 0, I get 0. So no profit, don't make any skateboards, don't make any money. Now help me with the calculator. putting in 0 here and 80 here.
5,200.
What is it?
5,200.
5,200? And then 20 here and nothing here. 1,000. So you're the owner of this business. What are you going to tell your factory workers to do? They need to make 80 specialty boards for a profit of $5,200. All right, that's it. You're done with those note sheets. So now we're going to get out our practice tests, which I gave you a while back. Everybody's got them. They look like this. Okay, you're on your practice test. Remember, what is the test going to look like? Exactly like this, right? So here we go. Here we go. Solve using substitution. Now, when we had a quiz over this, you all did great. You had better do great on the test. You got to show your work. I'm absolutely a stickler on these problems about seeing your work. William, what are you doing over there? You okay? All right, here we go. How do we do this? What do I need to do?
Subtract the 2y over.
I need to get something by itself. So maybe get this x by itself. So x equals 7 minus 2y. John, remember this substitution? Get one letter by itself. And then we're going to take this guy right here and plug it in to the other equation. Don't plug him in to the equation you got it from. Plug it into the other equation. So 2 times 7 minus 2y minus y equals 4. Do your distributive. Morgan, you working along here? Now I got 2 for y. Let me know if I did okay. I've made a couple mistakes today already. All right? Now that we're not done though, do not go on to the next problem. What do we do after we find y is 2? We have to go back and plug it in somewhere. I like to plug it in here, but you plug it in somewhere and it looks like x equals 7 minus 4, which would be 3. Any issue about that? All right, now we're going to solve using elimination. So we're doing the same kind of problem, we're just doing it differently. Right, so who remembers or has an idea about how we could multiply the bottom by 3, she says. If we did that, here's the top, not changing, and then multiply the bottom all the way across by 3. Does everybody see her logic? What's gonna happen? The y's are gone. That's the whole point. They are eliminated. So 11x equals negative 11. X equals negative 1. But like before, you aren't done. Don't stop. If x is negative 1, put it back in somewhere, anywhere. I'll just put it in that top equation. So negative 2 plus 3y equals 4. So I'll add 2, 3y equals 6. Looks like y equals 2. Kelly, is that making sense to you? All right. Well, now we got Kramer's rule. So we're doing exactly the same problem, but we're doing it a different way. Same kind of problem. All right, this one is newer to you. Does anybody remember how this Kramer's rule thing works?
Put in a matrix.
Well, yeah, we start by making a determinant of just the x and y numbers. Is that looking familiar? The x's, these are the x numbers and these are the y numbers. Is that okay with everybody? What does that equal? 4 minus negative 12. So 16. Now what do I do with that 16? 16 is the denominator of my answers, x and y both. How do I find the numerators? To find the x numerator, I have another determinant. But to get, I don't use these very same numbers. I take these right here and paste them in on top of the x's. Remember that? If I am solving for x, I take these numbers and put them right on top of the x numbers. So I'll have 1, negative 2, negative 4, 2. Right? So 2 minus 8. I did that right. I got negative 6. Did I do that right? So my x is negative 6. I know that reduces. I'll get it in a minute. Now I gotta find my y. How do I find my y? Same thing. Only I'm gonna cut those out and paste them here. Oh, whoa, 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 whoa. I got negative 7. So my final answer, negative 3/8, negative 7/16. I just reduced that. Everybody remember all that? All right, page 2. Oh, this is like the quiz you just took. What's 2a going to be? 2, 4, 6, Negative 2, 2, 0, 0, 6, 2. Now honestly, if anyone misses that, you should be smacked, right? That's pretty easy. How about B minus C? Now, first of all, you need to make sure you can even do it. Because remember, some of these problems aren't even doable. Is this one doable? Yes, because we have a 2 by 2 minus another 2 by 2. And the rule for subtraction and addition is they have to be the same size. The boxes have to be exactly the same size. So what do we get? Watch it, watch it, watch it. 1 minus negative 1. 2. Negative 1 minus 1. Negative 2. 2 minus 0. 3 minus 2. Everybody okay with that one? How about the next one? A plus B. Can't do it. Can't do A plus B. Why not? They're not the same size. So you either write can't do, write no solution, somehow indicate can't do it. All right, DA. There's D and A. All right, I'm going to multiply these two together. But before I do, I'm going to make sure I can. Remember how to do that?
2 by 3.
Y'all look so full of them and bigger. This one is 2 by 3. And this one is 3 by 3. Can they be multiplied?
Yeah.
Yep. And the answer will be a 2 by 3. Remember, these two have to match. And then the answer is that. Okay, so here we go. How do I get this spot right here? First row times first column. All right, there's a lot of numbers, so write them down. So I have negative 2, 1, and 4. Spread them out. And then 1, negative 1, and 0. So negative 2 and negative 1 and 0. What does that make? Oh, no. Negative 2 and negative 1 makes negative 3. All right. Row 1, column 2. So write down your negative 2, your 1, and your 4. That's your row 1. Now your column 1, 2, 1, 3. Negative 4 and 1 would be negative 3. And 12, I got 9? Is 9 right?
Yep.
And then top row, last column. Negative 2. Now I'm going to do the same thing, but I'm going to use bottom row, right? So now I'm going to write down my 0 0, 1, and -1. And then my first column, which is 1, -1, and 0. Yeah, that's just -1. 0, 1, and -1. 2, 1, and 3. -2? Got a 1 and a -3. And finally, 0, 1, and -1. And 3, 0, 1. Just -1? Everybody okay with that? Any question about that? What's E asking me for? The inverse. Anybody remember how to do an inverse? How do we do an inverse? So first we find the determinant, okay. So the determinant, just like with Kramer's rule, first we'll find the determinant. So that would be 3 minus -2 or 5. So my answer is going to be 1/5, 1 over 5, times a new matrix. Tell me about that new matrix. Back the original now. What are you going to do to it? You're going to take the 3 and the 1 and switch them. And then you're going to make that 2 negative and that 1 positive. And then you're going to put everything over 5. So you have 3/5, 1/5, -2/5, 1/5. And that's your answer. It's that easy. Anybody have a question about that? All right, how about F? A times C. Morgan's shaking her head. Can't do it because A is a 3 by 3, right? And what's C? A 2 by 2. And what's our rule? Those have to match. They don't, no answer. Next page. All right, what's going on with number 5? Do you remember? I heard somebody say first 2 columns. You put them here, right? And I always have to be very careful because sometimes I forget my negatives, so I want to make sure I include all the negatives. All right, so then what do? We take the first 2 columns and tack them on just like that, perfect. Now what? We start right here, always with the first number, and we multiply, and that gives me -15.
I got -16. Oh, no.
And then I multiply these and I get -4. And then I multiply these and I get 0. And I total them up. I add them up. Add them up. Now I'm going to turn around and go the other direction. Watch your signs. What do you get here? 6. And 10 and 0. That's 16. What do you do with those 2 numbers? 19, -19 minus 16. You should have gotten -35 as your answer. Anybody confused by any step of that? remember you do add them up, add them up, and then subtract. All right, so we have a vocab here. Here we go. What are the dimensions of this matrix? 2 by 4. 2 by 4. What is A sub 2y?
7, 5.
5. Why is it 5? Because we want the entry that is in the second row, first column. And isn't that a 5? The subscript is always row, then column. In the expression 2a, where A is a matrix, what is 2 called? Scalar. Remember that word? It's a scalar.
I really don't.
Oh, I hope I didn't forget to tell you that.
Yeah.
I did forget?
No, yeah.
Oh, I did tell you, okay. That's a scalar. That coefficient is called a scalar.
Okay, are all of them scalars or just the top one?
No.
The number.
2a, the number in front.
Oh.
What is a square matrix? Same number of rows as columns. So it's a matrix. I mean, that makes sense. 2 rows, 2 columns. 3 rows, 3 columns. 4 by 4, 5 by 5, 6 by 6. If it has the same number of rows and columns, it is square. Define matrix. Uh-oh, Ms. Ford gave this to you. A rectangular array of numbers. It is a rectangular array of numbers.
Can you go, say D one more time?
Huh?
Can you say the square matrix one more time?
What, Jonathan, what do you think?
I
Just use
zoned
the
out for
common
like
sense.
2 seconds. Fine.
No. What do you think? In your own words, what do you think it means to be a square matrix?
Square array.
Well, what does square mean? Same number of rows as columns.
Yeah, okay.
All right, next page. Woo, here's our linear programming. Notice, remember what the test looks like? Exactly like this, right? So there's gonna be one of these on the test, so let's practice this one. Here we go. All right, so you read it and start filling it in while I get things set up here. This one is a little bit different. So this one is a little bit different, but you should be okay. You should be all right. Some of it anyhow. Let's see. To stay in business, you must sell at least 10 hamburgers, but not more than 40. So what does that tell you about the number of hamburgers? It has to be somewhere between 10 and 40. So X is fixed between 10 and 40. That's X. I'll write it a little bigger down here because my box isn't quite big enough, maybe for those of you in the back. That interval is 2 numbers. X has to be between 10 and 40. Now what about Y? Is it the same thing for Y?
30 and 7.
It's between 30 and 70. Now the nice thing is, kids, those are 2 of your things to graph. You're going to be graphing those because we know that whatever X is, it has to be in that spot, and whatever Y is, it has to be in that spot. The number of hamburgers is X and the number of hot dogs is Y. And what is the total
45.
sandwiches that I can sell? 90. So I know that X plus Y has to be less than or equal to 90. And this time I put 5 lines in there because we still have these 2 gimmies. Where do I put the 0.33 and the 0.21? I don't have them in there yet. Well, no, the profit for a hamburger is 33, and the profit for a hot dog is 21. Now, is every number in there? I know this one's a little different. It's okay. We'll be fine. Every number in there? All right, let's start graphing. Again, with the size of these numbers, 10, 40, 30, 70, 90, should we go ahead and let our scale be 10 again? Does that make sense to you? So I'm going to graph this one first because it's the easiest for me.
Is there not an expression?
Oh yeah, I'm sorry. There is an expression to maximize. I didn't do it yet. What is it? Sorry. I skipped that part. 0.33x plus 0.21y. I was getting so excited about graphing, I forgot. Thank you. All right, so now I'm going to graph this one because it's just like all the others I graphed. These are a little bit different, but this one's just like the others. So I'll cover up the x. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's 0, 90. Cover up the y. 1, 2, 3, 4, 5, 6, 7, 8. There's 90, 0. There's the line. And I'm shaded everywhere underneath. I know you're a little bit confused by this problem. Just stay with me. Stay with me. Is that okay? Now, I want you to think about this one. That's saying x, whatever x is, think of your points. Whatever x is, it has to be between 10 and 40. So here's where x is 10, right? 23, and here's where x is 40. Now we're saying x has to be between there. So we're talking about this strip of numbers that are between where x is 10 and x is 40. We're talking about this strip of numbers right here that have x's in between 10 and 40. So I'm only going to shade in this part right here because I'm looking for the part that is red and purple both. So far, would you say it's that section right there? Does that look okay? Now, this says that whatever your y's are, they're between 30 and 70. So your y's have to be in this strip right here. Your y's have to be between 30 and 70. Which means I'm now looking at this piece. The piece with these corners. I got 5 corners this time, did you? You have to be between those vertical bars, between those horizontal bars, and then underneath that diagonal line. All right. right, here we go. Can we figure out what all those points are? This is a little tougher, but I think you got it. See this line right across here, kids? Every point on that line has a y coordinate that is 30. Every point on this line has an x coordinate that is 10. And over here, an x coordinate that is 40. So aren't two of my points 10, 30 and 40, 30? Those are two of them. What about this one right here? This is another easy one. That is 10, 70. Now, this one's a little harder, but not totally. Because what do we know about this green line?
70.
We know the y has to be 70. So, if they have to add up to 90, that must be 20, right? Hold up, we're almost done. And what about this point right here? Well, I know x is 40, so y has to be 50. Now, those of you that are saying, wait a minute, how do you know y has to be 50? We know they have to add up to 90. Now, what are you going to do with all those numbers right there? You're going to plug them right back in here, right? And you're going to put 0.33 times your x, 0.21 times your y. You're going to need a calculator to do that. And what will you be looking for? The one that gives you the biggest answer. And that's how many hot dogs and hamburgers you're going to make. All right. Have a great day. It's Friday.